Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to scale analog input and analog output of PLC SLC 500. Okay. So before go to create the program and scaling, let me explain a little bit about how to wiring. And I will use software RS Linx Classics and RS 500 to configure or to create the scaling. Yes, and here is the current loop that I already connected the cable to analog input. Yes, and here is the analog output channel number 1 that measured by multimeter, and I already select the function to the milliamp DC. Okay, so there are two channels for analog input, and there are two channels also for analog output for this module. Okay, so the wiring is very important. So if we cannot wiring, we cannot test the module also. Okay, that's why I would like to explain about the how to wiring. Okay, so I will show the overall drawing of this module. Yes, because here just two points or two channels, but I have some file that related to all terminal connection or wiring of this module. Okay, so let's go. Okay, here is the drawing of this module 1746 NI04I. It means that input and output is current. Yes, and here is the analog input channel. Yeah, there are two channels here. For terminal number 0 and number 1 is channel number 1, and here is the raw value. Yes, so if we use 4 to 20 milliamp, the raw data should be start from 3227. It is the standard. We can see on the manual operation of this module. Yes, and for channel number 2 of analog input, it is the same concept and the same raw value. 4 milliamp is 3227, and for 20 milliamp around 84. Okay, but for analog output, if we choose 4 to 20 milliamp, the raw value is start from 6242 until 31,208. Okay, for channel number 1 and number 2 is the same for analog output. Yes, so to scaling this module, yes, normally we can use 0 to 20 milliamp or 0 to 40 milliamp. 20 milliamp. Okay, so we can use it. So let's go to test this analog with the scaling. Yes, so first let's go to open RS Linx, and the first step we need to create the driver, right? So I will connect the RS-232 and convert by COM port. Yes. Okay. So first let's go to see the COM port of the cable. Where is my COM port? Yes. Okay, here. So right now I will use COM6 for this driver. Yes. So we can create driver by click here. Yes. And then click here. Configuration driver. And then we can choose the driver that we want. Yeah. Right now I will use RS-232 DF1 devices. Yeah. Because right now I will use RS-232 device. Okay. And then click add new. And then click OK. Yes. And here is very important. If we choose the incorrect COM port, yes, we cannot communication with the PLC. Okay. So for my COM port is COM6, right? Okay. So we can choose COM6. Okay. And then here no need to touch anything. Just click auto configure. Yes. It will detect automatically if we connected the RS-232 cable from our computer to the CPU or processor of SLC 500. Okay. So if it shows like this, it means that we can connect from our PC to the processor of SLC 500. Okay. Then click OK. And then click close. Yes. And we need to check, right? We need to check here. Okay, right now it shows 01 SLC 5/04. Yes, it is the CPU number. Okay, so the communication is okay. So next let's go to open the RS 500 English version. So we need to create the new project, right? To create the new project, let's go to File and then choose New. And we need to choose the CPU the same as the hardware, right? Right now for my CPU is 46K, yeah, 5/04. So I will choose it. Okay. And first we need to create the I/O table, right? Because right now I already connected the many I/O to the slot of rack. Yes. And here is the CPU. Yeah. So we can create I/O table by go to I/O configuration. And then click read I/O config. Yes. Okay. But before go to read the I/O configuration, let's go to communication, and then choose the system communication, and then choose the correct driver that we already configuration. Okay. And then click OK. Okay. And then we can read the I/O configuration. Yes, with the I/O configuration by push this button. Okay, and then we can choose the read I/O configuration here. The I/O will automatically generate and recite for us here. Yeah. So right now I use 10 slot. Yes. So analog input. Yes. Here is slot number 3, right? Picture that I already show on slide. Yes. Here slot number 3. So 0, 1, 2, 3. Yes. So right now the I/O configuration is already configured. Yes. So we need to test with the scaling, right? So before go to test the scaling, let's go to insert the rank. Yeah. By click here, insert the rank, and we can call the function. I will find the function that we will use. Yes, advanced math. It means that advanced mathematics. Yes. So we can use CP. Yes. Okay, so here is the function scale parameter. Yes, that we can use with this analog. Okay. So first we need to check the input, right? So let's go to input, and I will view as decimal. Yeah, easy to see the status. So if we would like to use the analog input 2 channel, yes, we can use here, drag and drop the input to the scale parameter, and here is the input minimum, and here is the input maximum. Here is the scale minimum, here is the scale maximum, and here is the output that we want. Okay, so actually I already explained about the maximum and minimum. Yes, for input, if we choose 4 to 20 milliamp, we can use the raw value from 3277, and for maximum we can use 16,384. Yes. For scale for scaling, we can use example 0 to 150 degrees Celsius, and here is the output. So output we can use another register that we want. Right now I will use this memory. Yes, floating point. Then we can compile and we can download. We need to save, right? Okay, I will save with the scale link, and then stop the CPU when we download the configuration. Okay, and then run the CPU back after downloading. Okay, so right now it will show around 37 degrees Celsius. Yeah, so if we would like to adjust, we can adjust. Okay, so right now I already put the current loop to the input, so the raw data is show a little bit, yes, and temperature show around example 37 something, yes. So if I adjust the milliamp, I will adjust the milliamp. Okay, I will adjust the milliamp to this point, yes. So if I adjust to 4 milliamp, let's see around 0 degrees Celsius, right? And the raw data around 3200 something, yes. So if I adjust to 8 milliamp, yes, 8 milliamp, it show around 37 something. If I adjust to 12 milliamp, yeah, 12 milliamp, so around 75 degrees Celsius. Adjust to 20 milliamp, it will show the maximum, right? Max scale. Yes, 20 milliamp max scale, around nearly 150 degrees Celsius, right? So the scaling input is correct with the raw data. Yes. If I adjust degrees, yes, degrees, yes, 12 milliamp around 75 degrees Celsius, right? Okay. So here is just analog input scaling. If we would like to use for analog output scaling, we can also create one more. Yes, I will test. So we can offline and then insert one more rung, right? Okay, and then drag and drop the SCP, yes, scale parameter one more. Yes, I will zoom out a little bit. Okay, like this. So analog output we can scale. Okay, for analog output we can use the scale from this one also. Yeah, example I will use this one to here. Yes, so if I adjust input by current loop, it will adjust, right? So I will scale this one from 0 to 150. Yes, and then the scale, yes, the scaling analog output will be here, right? So if 0, it will 6,242. Yes, it is inside the drawing that I already explained right here. And for 20 milliamp, around 31,208. 31,208. 0H. Okay. Then we can download. Yes, compile and then download. Error, right? Error 1. Let me see here. Okay, output. We need to put the output also, right? For analog. So we can go to output and then choose the decimal. And here is the analog. Yes. So if we would like to use the output, we can use here this one, input output, right? Okay, we can use 03.0. Yes, and we can compile again and then download to the processor again. Sorry, yes, it slow a little bit. Okay, so right now I will zoom out a little bit. Okay, for easy to see the status. So right now, let's see here. If I adjust the milliamp, okay, if I adjust the milliamp to 4, let's see the output is 4 also, right? Because I already connect the cable from this terminal for channel number 1. Yes. So I adjust to 8 milliamp. The output will generate 8 also, right? Because we already scale here. Yes. Okay. 12 milliamp. 16 milliamp. Yes. And 20 milliamp. Yeah. It shows the same between input and output. Okay. So example, if everyone have the VFD here, we can use the 4 to 20 milliamp and we can control it by adjust only input. Okay. So if I decrease 16, 12, 8, 4, yes, the same, yes, flexible, follow the scaling that we already parameter here, yes. So we can scale any number that we want. Yes, it will follow by using the function SCP or scale parameter. Okay. So I hope this video is just example and useful for everyone that would like to scale the analog input and output of PLC Allen Bradley SLC 500. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.